Let's work this example problem from section 5.1. It says to find the area of this shaded region. And so we've got this this blue line is the equation, the graph of the equation y equals negative x plus 8. And this red parabola is the graph of the equation y equals x squared minus 8x plus 14. To find this area, we're going to want to set up an integral. If we think about what a typical rectangle would look like, you know, we'd have a rectangle, we'd want it, probably do a vertical rectangle here because I can have the top of the rectangle then always along the line, the blue line, and the bottom of the rectangle always along the red parabola. And a typical, you know, rectangle would look like this. And we know then that the top of the rectangle is along the line, so that's a y-coordinate of negative x plus 8. And the bottom of the rectangle is along the parabola, so that would be y equals x squared minus 8x plus 14. And we're going then from this point here, which is x equals 1, and we're stopping at this point here, which is at x equals 6. So this rectangle, its length is going to be the distance, the difference between the y-coordinates, this y distance, delta y, and the width is going to be that little delta x. X is going to be my independent variable here. So I'm going to do an integral to add up all these values. My x-coordinates are going, again, from x equals 1 to x equals 6. So x is going from 1 to 6. I'm going to take the top, to get my length, I'm going to take the top y-coordinate, that's going to be negative x plus 8. And I'm going to subtract the bottom y-coordinate, which is x squared minus 8x plus 14. But I've got to be careful when I'm subtracting. I have to subtract off that whole bottom y-coordinate. So I need to put that whole y-coordinate in parentheses. And then I'm going to multiply by the thickness of the rectangle, delta x or dx in this case. So that's going to be the integral that would find the area of this shaded region. So let's evaluate this. We're going to do some distributing here. So negative x plus 8 minus x squared plus 8x minus 14 dx. So when we combine like terms, we've got negative x squared, that's my highest power term, negative x plus 8x, so that'll be plus 7x. We get plus 8 minus 14, so that'll give me negative 6. Now I'm ready to take the antiderivative. So when I take the antiderivative, the exponent's going to go up by 1, and then I'm going to divide by the new exponent. And then I just get 6x. And that has to be evaluated then between 1 and 6. So I'm going to plug 6 in to the function and then 1 into the function and subtract. So when I plug in 6, we just get this, right? So I get negative 6 cubed over 3 plus 7 times 6 squared over 2 minus 6 times 6. I could put parentheses around that, but it doesn't really matter. Where the parentheses will be important here is around the 1, and I'm going to go down a line so I don't run into that x equals 1 there. So if I plug in 1, I get negative 1 cubed over 3 plus 7 times 1 squared over 2 minus 6 times 1. And again, that's all in parentheses. Notice that both these negatives here, this negative is not in parentheses with the cubed. So the x cubed happens first and the negative happens second. That doesn't actually matter much with cubes, but with squareds it would be more important. 6 times 6 times 6 is 216. 7 times 36, 7 times 30 is 210, plus 42, so that would be 252 over 2, minus 36, minus, I get negative 1/3, plus 7/2 minus 6 inside parentheses. So I'll just start cleaning up here. So I distribute, I get plus 1/3, minus 7/2, and plus 6. So negative 216 plus 1/3. So that's negative 216 plus 1. That would be negative 215 thirds. I get plus 252 halves minus 7 halves. So it's going to be plus 252 minus 7 will be 245 over 2. And then I've got the minus 36 and the plus 6, so that'll be minus 30. So I'm going to need a common denominator of 6. So negative 215 over 3 times 2 over 2, plus 245 over 2 times 3 over 3, minus 30 over 1 times 6 over 6. So that's negative 430 over 6, plus, let's see, 45 times 3 is 135, plus 600, 735 over 6, minus 180 over 6. So that's 735 over 6 minus 510 over 6, 610 over 6, right? Yeah. So that's 125 over 6. That would be that area. Now, if we look at that, 6 goes into 120 20 times. That's 20 and 5/6. If I try to estimate this, well, I don't know. If I took the triangle just from the going along here to here, that's 8 by 8. So if I did the whole rectangle, that would be 64 square units. Half that would be this triangle, which would be 32. We're getting this is 20 and 5/6, and we're leaving out quite a bit of that. This little bit would maybe fill in here, but we'd be leaving out all of that. That seems like a reasonable area to get. So that would be our area.